Okay, so this is the microwave with its cover removed. I am going to remove its high voltage transformer and use it to generate arcs. It's a very old microwave. I was amazed when I pulled this thing apart. I saw this. It's a schematic diagram of the wiring. This was from back in the days when you were supposed to service your appliances when they broke, not just replace them. And there is the high voltage transformer. That's what I'm after. I'm going to remove that from there and should be able to put 120 volts in and get quite a few volts out. I can't read the ratings on it. I'm not even sure it says exactly what the output voltage is, but I know it says warning high voltage. That's something. Okay, so this is the microwave transformer without current limiting, and we're going to make an arc. Turn it on. There you have it, an arc. We're going to make an arc between two electrodes made out of pencil lead. Vertical arc. As the ionized gases rise up, you can really drag the arc distance a long ways because it's not trying to rise away from the second electrode, it's actually rising towards it. Okay, so here is the problem with using a Christmas light plug to connect a microwave transformer and then to arc it. Things melt. Yeah, this gets pretty hot too, but it's made to do that. This though is not. The fan is actually in parallel with the circuit. It runs whenever the system is plugged in, even if the transformer is shut off. The reason is because the transformer gets very, very hot when generating arcs because it's shorting. So when I turn on the switch, that fires up the transformer, and from the small winding that's designed to light up the filament on the inside of the magnetron in the microwave, I've got this Christmas light hooked up just sort of as a warning to tell me that it's energized and generating 2000 volts. The screws are attached to the output wires of the transformer. There's a tiny copper wire on top of them that will melt when the power is turned on, and this will strike it out. Is a water arc. And the water arc will get the nickel very hot, assuming that doesn't happen. Now this also heats up the transformer incredibly, but the nickel is just getting real hot. You can see that, definitely melting that nickel. But the problem with this is, like I said, it really gets that transformer hot. And as you can see, I just lit the plastic. Okay, so I have 63% alcohol hand sanitizer on this metal. Okay, so now it's burning. Now look at how large the arc distance is. How far I can be away from the metal before the arc will strike. The hotter the flames get, the larger this distance is, because flames are ionized gas, just like an arc. Essentially the same thing. It's also why when I strike the arc, the flames appear to get bigger. So they do. The flame is actually conducting the electricity. You can see now it only takes, I'm a centimeter off that metal striking the arc, whereas normally I'd have to be several millimeters away for the arc to strike. And of course